Welcome to The Explainer. Today we are diving deep into a core piece of AWS Lambda that every single developer uses, whether you know it or not. We're talking about the runtime.
So let's start with this. You write your code, you zip it up, you upload it, and then what? It just kind of works? Well, that magic in the middle has a name, and really understanding it is the key to building serverless apps that are more secure, way more efficient, and easier to maintain in the long run.
So here's our game plan. We're going to start with the basics. What is a runtime anyway? Then we'll get into how they're kept up to date, what happens when they get old and retire, what you're actually responsible for, and then we'll look at some really powerful advanced options.
Okay, first things first. Let's peel back the layers and look at the engine that actually powers your code inside of Lambda.
The best way to think about a runtime is like a specialized little operating system just for your function. It's a totally secure, isolated environment that's perfectly tailored for your language of choice, whether that's Python or Node.js or Java, you name it. It's the middleman that handles all the communication between the Lambda service and your actual code.
Now, this is where it gets really interesting, because your choice of language has a direct impact on performance and, yeah, probably your bill too. Interpreted languages like Python or Node are super fast to start up, which is perfect for those quick, frequent jobs. But compiled languages like Java, they might take a little longer to warm up, but once they're running, man, they can tear through heavy-duty computations much, much faster.
So picking a runtime isn't a one-and-done thing. Now we got to talk about keeping them patched, keeping them secure, and, this is the important part, how much control you actually have over that whole process.
You know, one of the huge wins of serverless is that you get to offload all that operational headache. AWS does the heavy lifting here. They handle patching the runtimes with security updates, bug fixes, all that good stuff. But, and this is a big but, that doesn't mean you're just a passenger. You have way more control than you might realize.
And here are the 3 ways you can manage those updates. You've got auto, that's the default, and honestly, it's what you want 99% of the time. Lambda just handles it all. Then there's function update, which ties the patches to your own code deployments. And finally, you have manual, which you should really only think of as an emergency brake if you need to roll back an update that's causing problems.
So the crucial takeaway here is that while breaking changes are super rare, you can pretty much guarantee you'll never have a problem if you follow these simple rules. The big one? Always package your own dependencies, especially the AWS SDK, right there in your deployment package. That makes your function a self-contained unit and prevents any surprises when the runtime underneath it gets an update.
Okay, let's tackle a subject that can give developers a little bit of anxiety. What happens when a runtime you're using gets old and is about to be retired? The good news is AWS has a super clear, super predictable policy for this. No surprises.
First off, this isn't random. A runtime gets deprecated when the language version or the operating system it's based on reaches its own end of life from the open source community. So once, say, a version of Python stops getting security updates from the Python community, AWS will then deprecate the matching Lambda runtime. It just makes sense. At that point, your functions on that old runtime won't get patches and aren't eligible for tech support.
And this timeline is your best friend when it comes to planning. You get a massive 180-day heads up before anything even happens. After the deprecation date, there's a phased rollout where they block you from creating new functions and then later from updating old ones. It gives you a huge, comfortable window to test your code and migrate to a newer runtime without any late-night emergencies.
And you are not going to be left in the dark about this. AWS will make sure you know. You'll get emails, you'll see alerts right in your health dashboard, and you'll even get a specific check in Trusted Advisor that lists out every single affected function. They make it really hard to miss.
So this all leads to a core concept in the cloud, the shared responsibility model. Let's draw a really clear line in the sand about what AWS is on the hook for and what you need to own.
This table just spells it all out perfectly. If you're using the default auto mode, AWS does pretty much everything. Your only job is to keep an eye on things and roll back if something looks weird. If you pick function update, well, now the ball is in your court to deploy regularly to get those patches. And for all you folks using container images, AWS gives you the new, updated base image, but it's on you to actually rebuild and redeploy your function with it.
All right, for our last section, let's go off the beaten path a little bit. What if you want to use a language that isn't on the standard list, like Go or Rust or even PHP? Well, that's where OS-only runtimes come in.
These OS-only runtimes, with names like provided.al 2023, they basically give you a clean, bare-bones Amazon Linux environment when you can run, well, almost anything you want. It's awesome for languages that compile down to a single binary. It's what allows cool community projects to bring languages like PHP to Lambda, and it gives you the ultimate power to just build your own custom runtime from the ground up.
So when you build your own runtime, you're creating a small program, usually called a bootstrap file, that talks directly to the Lambda service APIs. It just sits in a loop, constantly asking the API, hey, got a new event for me? It passes that event to your function, and then it sends the result, or any errors, right back to the API. It is the absolute peak of flexibility and control.
And that brings us to the end. As you can see, a runtime isn't just some static thing you set once and forget. It's a living, breathing part of the Lambda service. And knowing how they evolve and what your role is in that whole process is what separates good serverless apps from great, future-proof ones. So the question I'll leave you with is this: are your functions ready?